Hello, and welcome back. This is episode 6. Thank you for returning. I'm here with my teammates, and once again, you can reach us at mappinghour@esri.com, and we hope that you have taken advantage of the recordings that are at esriurl.com/mappinghour. A reminder that you need a login for the remaining sessions, and if you don't have one, then you can submit a request with your survey at esriurl.com/mappinghour. And last time we finished up the first 5 with episode number 5, going through metadata, all that important information that holds this whole infrastructure together, allows everybody to be working along with all of the other elements, the URLs, understanding those strings, the item IDs, the item pages, tags, searching, groups, all that great metadata stuff. That's going to be really important for everything that we do from here on out. And starting today in episode 6, where we're going to be working with data and tables and coordinates and GPS. Without further ado, I get to start today, and let me jump to a document that's called Table Time. This is a document that has been around for actually a number of years because these characteristics, these bits of information are timeless. And they talk about the importance of some background elements, being able to navigate and work with drives, folders, and files, and then the ability to work in data tables. And this is a reading and an exercise. So here we begin the reading. So let's think about tables. And I want you to think about the family that you see. This is the Smith family. There's dad, mom, child number 1, Tony, child number 2, Terry, child number 3, Tina. Okay. Gosh, it was just really hard to process all that information in this fashion. This is not an easy way to do this. And if I asked you a question and said, hey, what's their average weight? How many eye colors are represented? If the family goes to a lake, who's going to be happy? It's hard to look at this. But there is a way to look at this that makes life easy. And that's with a sort of a linear process. We think of them in terms of like things. This data table makes life so much easier because you can see what's there. You can see the commonalities. You've got rows of individuals going across. You've got columns of the like things. This is what GIS relies on. These rows and columns, the data that is behind the features. These are the attributes. The rows are the features. Think about this on a map the same way. The rows in a table are the features. The columns in a table are the attributes. Now, there's a problem with this data table. If I look at the empty cell here with weight for mom, I don't see a weight there. Can I just think of it as 0? 0 won't work. Mom weighs something. And how do I cope with that? And even more, if I look at the height column and I want to sort these won't sort from the lowest height to the highest or the highest to the lowest. These have non-numeric characters in here. So they're going to sort as in alpha sequence. So 411 is before 42, and then comes 510, 57, 58. And so you need to be thinking about these things in terms of numbers and having your tables with absolute fidelity to these. If it's a number field, it can't have anything that isn't numbers in there. If it's a non-number field, it can do a variety of things. Like you can have 10th grade in here and college degree. We've got a variety of characteristics in here that you might have no similar elements in terms of their description. If you had something A, B, C, D, E, that would be, you could alphabetize these things. And here we've got sort of apples and oranges. So data tables, when you're working with GIS, you need to be thinking about, I want to have tables with absolute precision in terms of their all numbers. If I've got a numeric field that I want to work that way. And otherwise, I can deal with them as categorical information. What does this allow us then to do? Well, we can think about this like a computer and start thinking about this in terms of a task. Let's focus on task 1 here. We could walk through a task that is, come up with a description of your family and start doing a name and 3 characteristics that are alpha and 3 characteristics that are numbers, like height in inches, something like that. And then start thinking about this in terms of GIS and go around the school grounds and start thinking about this in terms of number fields and string fields that will allow you to do something special with it. That's what we're going to be seeing a little bit later today. But as I'm looking at this, I see latitude, lat, y, and long, x, and a couple of these have some minus numbers in this. Minus numbers for latitude and longitude? How can that be? How can we have latitude and longitude with minus numbers? Well, look at this. It's math class. We've got the axes. And I've got there's the this axis and the this axis. Let's see, what are they called? This one was the x axis and the y axis. Now, as you're looking at me, and this is the x-axis, and when you go that way up the x-axis, as you're looking at me, when you go that way up the x-axis, you're going in, I'm hearing positive numbers. Yes, you're going in positive numbers up the x-axis. And that way, you're going to negative numbers. And up the y-axis, you're going this way to positive numbers, and that way in negative numbers. Now, we're in geography class. We're looking at a world map. On a world map, this is and my colleagues are mouthing the equator, the equator, the equator. Yes, there they are. And this one is the prime meridian. Of course, they're saying that. Yes, indeed. Okay, so this one, X, this is actually tracking longitude? Hey, I thought this is a latitude line. Yes, but it's tracking longitude. As you move down this line, you're changing your longitude. Any one of these lines, you're changing your longitude. You're going from 0 at the center to positive that way and to negative that way. Same thing with your latitude. Wait, this line, this prime meridian, is a longitude line. Yes, but it indicates the change in your latitude as you move up and down. So that way on the x-axis is going to be positive. That way is going to be negative. That way on the y-axis is going to be positive, and that way is going to be negative. That Keep those in mind as you work your way through here. And with that, remember this table time exercise. There's all this information in here that you can read through, and outside, when you can get outside and take this back to school even, and go through some activities just working with latitude and longitude, X and Y in these data tables. And keep the Smith family in mind as you're thinking. Rows and columns, features and attributes. This is the feature attribute table just like you see in a GIS data set. And that's table time. I'm going to pause it here and turn it over to Kylie.
Thanks, Charlie. That was great. So what I want to do now is take this idea of tables and look at how that table can come into our GIS and onto the map. So I'm going to go ahead and start sharing my screen. And you can see you're looking at a map that you've seen before, right? We've talked about this map. This is our last month of earthquakes. It's some data on a map. But what I want to do now is you're going to get a quick review on things we went over the previous episode as well, where we're going to go look at some of the metadata. So if we go to the About tab, you can see more details on this map. So I'm going to go ahead and open that in a new tab, which I've already done, and we can look at this metadata. Well, one of the things you'll see in the metadata is where we're actually getting this information, and it's from the USGS site. Now, you could get the link here, or alternatively, you could just use Google. We know USGS is an authoritative source on earthquakes, so we can just search USGS earthquakes. Well, right here, I can see a page that looks like it might be what I want. I can go ahead and open that page, and I can see some information on the USGS site about earthquakes. Now, of particular interest right now is if I come down and I notice this little section. We have some notifications, feeds, and web services. What those mean is basically it's information that's going to get shared out in a special format, and our GIS can use that. And look, use real-time web services for your own applications. That's kind of what I want to do. So I'm going to go ahead and click on that link, opening it up. Now, what we were just talking about was tables. And a similar thing, when I'm working on tables in a computer, I often use a spreadsheet. So I see this thing about a spreadsheet format. And let's go ahead and jump in there. Now, for those of you who paid close attention, you may notice that if I jump back here to the metadata about our map, the link that shows here where we're getting the information is actually the same as the spreadsheet page that we're landing on. But we've gotten there, no matter which way we got here. And we can see that there's information here called feeds, which, as I mentioned, is just some data that's being put together for us. And look, the past 30 days. Well, our map was the last month of earthquake. Past 30 days, it's probably that data that we were talking about. And we were looking at earthquakes 2.5, magnitude 2.5 and greater, and I can see that here. And I can click on that item, and it'll go ahead and download it. And you can see right here, we're getting a download. And we can look in the downloads on our computer, and there it is, a CSV. Well, a CSV stands for a comma-separated value. And I can open that file in any type of program I want, even just like Notepad. So I'm going to pull up my favorite Notepad app, and we can see this table. Looks great, right? Can you tell where every earthquake was? What was the magnitude of that fifth one listed? Yeah, I'm not a great computer either. I really struggle to read this. And while I understand it's the right information and it's comma-separated values, I can see the commas. Oh, and in this purple line, I can tell what the different things are. It's a pretty hard format to read. But one thing that's really cool is we have spreadsheet programs that help us to better read this type of information. So the first thing I'm going to do to make this a little bit more readable is take it into Excel. So here's our same data. This is looking a little bit more like those tables Charlie was talking about. And we're not going to spend a lot of time here because I want to make it even more powerful than looking at it in Excel. But what I do want you to notice is we have this latitude and longitude. Well, we've just talked about those a little bit, as well as some depth information and magnitude and a whole bunch of other information about the earthquake. But key here that I want you to notice is we do have latitude and longitude, or a location, for each of these records or rows. So now what I'm going to do, go ahead and minimize that, and I'm going to jump onto a new map. So this is just the same as when we came into Arcgis Online before, and we can see that we're not signed in, and we're going to go ahead and click Modify Map so we can play with it. Now what I want to do is jump back to that file I downloaded. So, got a CSV file of information, got a map. CSV file's on my computer, maps in a web browser. I really wish I could take that data, which has latitude and longitude as we saw, as well as all this other cool information, and instead of having to read that table and trying to understand where they are, I want to just put it on my map. Well, what if I just try that? What if I just drag this file and put it on my map? That was pretty cool, right? Like that's all I had to do. I just dragged it and dropped it. So again, it's kind of like you would use if you're moving a file between two folders on your own computer. But in this case, you're taking it and you're dragging it right into your map in the web browser and online. And it's taking that information and it's putting it onto the map. All right, so that was pretty cool. It's helping me with style, as we've seen before, because often when we add data, the first thing we want to do is style it. But I'm not going to worry about that right now. Right now, I just wanted to get the data in here. So let's go ahead and cancel out of that and look at what we've got. 2. All right, I have to admit, I'm not even sure where that's coming from. So what I'm going to do is give this a much better name. And when you click these 3 dots or the more options, you can see there's an option to rename your layer. So I'm going to go ahead and do that now. And I will say last 30 days of 2.5 mag or greater earthquakes. And you might have a much more short name or succinct, but that'll work for now. At least I can remember what that data is and why it matters to me. All right. With this data, you've seen in some of our other episodes, you can actually view the raw table of information. So if you remember, this button here that looks, well, like a table, will show the table. So let's go ahead and click it, and you'll see very similar to what we were looking at in Excel. In fact, I'm going to bring up Excel and make it smaller so we can see a little bit of both of them, just for a second. Well, we've got our time, our latitude, our longitude, our depth. Okay, yeah, we've pretty much just taken the same table and brought it in. So we can go ahead and get rid of Excel. We know the information we want is here. But part of why I did this was so I didn't have to look at the table and I could look at the map. So I'm going to go ahead and close this. And you can see, yeah, I've got all my dots here. That's great. I can, well, okay, it's not great. If I look at this map, all these colors and different sizes, the information was really cool. Well, if I look at this, I can still see the dots. And I remember, right? These maps are interactive. What's something I can do to see more information? Right, I bet Charlie's thinking it. Click on one of the dots, right? Play with this data, see what you learn. So I'll click on one. Okay, cool. I see the time, I see the latitude and longitude, I see the depth and the magnitude, all this information that was in the table, I can view right here for that one record or feature. So that's pretty cool. I don't have to look at the table and I can see the information for that specific point right on the map. Now, I'm not an earthquake expert and I don't really need all of this information. I liked that other map where it just focused on those things I need. And one of the great things about making your own map, you have control over what's presented in this pop-up. So let's go ahead and look at that right now. We come back over to our layer in the content and we look at more options and we click on that choice, you can see that you can configure the pop-up. Now, as we've mentioned, the pop-up is that little window that appears when you click or interact with a feature on the map. And then we come in here, we can see all kinds of things we can do. Well, look, these field attributes will display. Charlie said the column or the attribute, those are kind of the same thing. I'm seeing more than I want, so let's configure that. In fact, there was a lot more than I wanted, so I'm going to click at the top here to turn all of them on so that I can click at the top again and turn all of them off. Now I'm starting from a blank slate. I thought the time was really important. I'd like to know when the earthquake was. And in particular, the things we were looking at before was the depth and the magnitude. So I'm going to keep those as well. Now, latitude and longitude were important to me until I put it on a map. But now the map's got that for me. So I'm going to leave those out of my display. I'll go ahead and click OK. And click OK again so that my changes take effect. Let's try clicking on one again. That's a lot cleaner. That's more of the information I'm concerned with. It's not the best formatting though, and you can make it look a lot nicer. We can go back in and configure pop-up, and we can do things like here, click this little plus button and add some information like the magnitude right into the title. Go ahead and click OK again so we can see what that looked like. There, magnitude's pretty important. Let's really highlight that information. And this is great, but you know what? There are some more fun ways to see this. So I'm going to go ahead and configure that pop-up again and show you another part of it that's really powerful. And you can see here, there's a display field and it has some choices. So if I expand on that, I can see that I can do a list of the attributes. I could choose one field and just show it. Well, I had a couple that I wanted to see. A custom display or nothing. Maybe just the title is all I need. If all I need is magnitude, we could go with that. Get rid of everything else. It's already there in our title. But today that's not enough. I do want a little bit more. So I'm going to go with a custom attribute display. And let's configure that one. Well, in here, I can just write. And let's see if we go on and we'll put a time. There was a... Let's put in our magnitude, and you'll see similar to the title, it's entering these curly braces with a word inside. What that means is go to the table for this particular feature and pull out the value that you find there. So the magnitude of this particular earthquake is going to come in. When I open the pop-up, I'm not going to see the curly braces in the word magnitude, but instead the value that was in that field of the table. And we'll magnitude earthquake. Whoops. At a depth of, and let's go ahead and stick our depth in. All right, so that gets a little bit better. And I'm going to go ahead and say OK on this. Go ahead and say OK again to really save those changes into our map. And let's see how it looks now. Wow, that's pretty cool. Now, it's interesting that at the beginning of this presentation, Charlie had some statements as lists, right? And it talked about the family and their information all in one line. And he said, it's hard to remember and process that, so we want to go to the table so that we can use all that information and sort on it and process it. And here I've gone the other way, right? We had the table view of just the facts, and I've processed it into a sentence. Well, we had different audiences. Charlie was talking about using the information, finding some statistics. Right now, I'm presenting the information. I'm sharing it. So I want it to be a little bit more fun to read and inviting. So this isn't the view I would use as I was trying to process the data, but it's what someone might want to see as the output of that processing. All right, so we've looked at some of the pop-up stuff, and there's a ton you can do here. I'm not going to go any deeper right now, but there are some great blogs out there, and we'll be sharing some resources on that later. All right, I just have time to show you one really cool thing with the styling, because one thing that was really powerful that we saw in a map in an earlier episode was how multiple attributes or fields of information were used to set what those symbols looked like. So similar to before, we click on that style chat, and you can see the key is right here, choosing what you want to show. Right now, we're just focused on location, which is that latitude and longitude, or where on the map the point goes. That's why you'll see all my points are about the same color. They're all the same size. We can get more than that. Now, let's instead look at the magnitude. And look, add another one. Let's look at that depth, right? Those two factors that we were curious about. And now you're seeing a little bit similar to the other map, but now I wouldn't even need 2 layers. Now, we'll get to this a little bit more later, but notice if we go to this last month of earthquakes, and I'm going to jump back to the metadata, when it was last updated, back in 2017. So it is still a powerful map, but there are things we can do in new ways now. And that's what I'm doing right now. So now I can take 2 attributes from the same data and symbolize based on both of them in one symbol. I wouldn't even have to add 2 layers to the map anymore. Now, similar to before, you can go into the options. You could go in and look at the magnitude or the depth. You could change maybe how you're doing it, pick a different shape. You know, all of those options that you had before, you have still. And we could go into here and we could say, you know what, I would like a different one. I could pick a different fill. Maybe I want mine to go to red and I could choose that. Okay, that's better. And I can play with this. I can switch which way the color ramp goes, what means deep, what means shallow. But the key here is just to understand that you can do this on multiple of those attributes. The one other part that's really cool here that I want to show you in the symbols that can be very important as you're symbolizing data by multiple attributes is to make it really easy to see what it means. And one way I can do that is through transparency. So I'm going to go ahead and increase the transparency on this and say, okay, now you can see that I've made things a lot lighter. But in doing so, the spots where they overlap are visibly darker. Now at a scan, I can not only see, oh yeah, there were earthquakes about this size, but look, right here's really a darker red spot. There's more happening right there. There are more of these overlapping, and those transparencies are adding up to create a darker color. All right, I know I've gotten into a lot here. We looked at finding a CSV, just dragging and dropping it right into our map, configuring the pop-up, and the pop-up is one of the most powerful parts of these maps. It's how you really communicate that data, and you're going to see it used, well, even outside this map viewer in later episodes, and it's going to be awesome. So I'm going to make you wait for that, but really understand those pop-ups, play with them, configure it, try something you don't think you should do. How does it work? And when things aren't going well, just refresh, right? Now, if you're logged in, you could even save where you're at right now, play a bunch, and then be able to refresh to go back to where you were before. I worked not logged in today, just so that I could show that. But you get the idea. All right, I'm going to go ahead now, and I'm going to go ahead and turn it over to Tom, and we're going to look at some more stuff about this.
Kylie, that was so cool. I have a question. I'm hoping you can help me out. I've
Sure,
got an
what's
activity and a map that I want to basically display the same kind of data you just did. It's actually a GeoInquiries map, and I want to be able to show recent earthquake data on it.
I think I know what GeoInquiry you're talking about.
Do you?
Let me share my screen. Let me see if I guessed it.
Let's see. You got it.
All right. Earth moves. This is a fun one.
It
I
is.
have to admit, being a native Californian, I've lived through some interesting earthquakes, and I do find them fascinating.
The problem with my map is that for this activity that's up all year round, when schools and kids use it, it's pulling the same historic earthquake data set. Now, I saw what you did with Charlie's, where you grabbed the last month of data, but what I'd like kids to be able to see is the last month of data from the time they open up the map.
Gotcha. Well, we can definitely do that too. You know, that's what Charlie's map had, right? It was always the last 30 days.
That's what I want to see. If you'll open up the map, there's maybe one more gotcha in there that I'm hoping we can talk through.
Okay, let's check it out. All right, I've got the map up here. Oh, this is a different looking earthquake map. So it's the same kind of concept, but I can see some slightly different information here on the map. Cool.
And you might have noticed that the map's a little different shape than the other map that we looked at.
This map doesn't fit right. I see some like grayish color in the corners here.
Corners, yeah. I think if you zoom out a little bit, it'll be a little more obvious, especially for those of our friends who aren't maybe cartographers. Yeah, so now we have an interesting shape on our map. This is actually a projected map. So the data have been transformed a little differently as we tried to move it from a globe to a piece of a flat surface. And this is actually called a Robinson projection. The cool thing about Robinson projection, as opposed to Webb Mercator, which is what we saw on pretty much every other map we use, like that one, is that the Robinson projection is really good at displaying data, particularly at the mid-latitudes. So it's better at holding size and shape for most of the world. It gets a little weird at the top, at the North Pole and at the South Pole, but right in the middle there, it's usually pretty accurate. So I'm hoping that the use of this Robinson projection doesn't cause us a problem as we try to bring in your live data set.
All right, well, let's go try it out. So one thing I'm actually going to jump back to, because I think this is really important for what you're trying to do here, Tom, is looking at this map again that Charlie put together. And as I mentioned, we can go to the About and we can see the more details. And you can even see right here, it was last modified in March 2017. Yet when I click on the map, similar, I think, to what you want, this earthquake is from March 29th, 2020. So that's definitely not within 30 days. Is that what you're looking for?
That's it. It's the last 30 days from today.
Great. So just a minute ago, working with Charlie, I dragged and I dropped a CSV on. Now, that was a CSV that I downloaded. That was a static set of data. And that works great on some projects. When you've done some data collection, you have a set of data, or maybe you really just want to focus on that window in time, but it's not changing. Now, in this case, I think you're going to want something different. So let's go ahead and we're going to look at the details from Charlie's map, because it's going to give us another hint. And the hint I'm going to look at is what he is pointing to for his layers and the URLs of them. So I'm going to hover the map down here, and you may see at the bottom of the screen, it tells us the name of the CSV coming from the USGS site. So for example, if I click on one and I was to just click it, we're getting a download, right? So that link wasn't something already downloaded. It's actually going out to the USGS site and saying, grab that data right now and use it on the map. So we're going to do something similar for your map, Tom. So if we come in here, I'm going to look at the map and realize that I need to add it. I'm going to have to click Modify Map, just like we have in all the exercises, so that I can actually change what I need here. And I'm going to jump over to the spreadsheet format page on USGS. Right, this is where we clicked download before. It's that same URL that was in the details or the description of Charlie's map. And I have that same link right here that last time, and I can do it again. If I click it, it downloads it. Well, I don't want that now. Instead, I'm going to right-click on that and copy the link address. Okay, so I don't want to break it. I don't want my own copy, which is what a download is. And in fact, if you watch as I'm clicking download, I've now got a whole bunch of these. I can go to my downloads folder. You can see I've got 5 of them. Those are all separate. I could delete one and the others would still be here. I could change one and the others would be the same. That's not what we're looking for.
That makes sense then. As soon as you download the data, it becomes static.
Right, because I've downloaded it. I've said, hey, I want a copy of that for myself. So let's go back, and I'm again going to click copy link address, just because sometimes I forget if I'd done it. And I'm going to go back over to our map. This is a link, so I can't drag and drop it. Like, that just doesn't work the same. So what I'm going to do now is go to this add menu. And again, you've seen this in other episodes. So in this case, we've done some search before. That's not what I want. Well, I don't want from a file, because that sounds like my computer, and again, we're getting static, right? But there is this add a layer from a web. So that web, URL, those things kind of go together. So let's pick that option. And yep, look right here. We can enter a URL. So you can pick different things. And who remembers what the format was? Tom? What was it when we downloaded it?
I think it was a CSV, wasn't it?
Exactly. And we're going to go ahead and pick that option. And when we enter the URL, just by pasting it in there, and that, for those of you who don't know, Control V is going to go ahead and take that thing you copied and paste it right in for you. I know sometimes people aren't as comfortable with those keyboard shortcuts. So here you can see it's got that whole URL to the CSV or path to it, but it's not on my computer. It starts with HTTPS and earthquake.usgs.gov. So that's their version of it. And I'm going to go ahead and click Add to Layer. I'm going to wait a second as it works on it. Do you notice? All those dots appeared. And look,
wow,
it's even doing some styling for me right off the bat this time. So let's leave their styling alone for now, because we did already look at that. And there is one thing I want to make sure you know, Tom, when you do this for your map. And that is, again, we have 2. You can do all the things you did before. You can rename it. You can restyle it. You can create a good pop-up. Everything we did still applies. But there's one really important step when you're working with a feed of data. And that is, Tom, why did you want a feed of data?
I wanted it live.
Right. That's the whole point. Always the latest data. We want that connection. We don't want a downloaded copy. And the trick to that is here in More Options, there's a refresh interval. Now, what that does is it tells your map how often to make sure it's showing you the latest data. Now, when you've attached to a CSV, it's going to refresh anytime you open the map. It does refreshes at certain panning movements and certain zooming in and zooming out. But what I want to say is, even if I don't touch this map the rest of the afternoon, when I come back in 3 hours and want to look at it, and because maybe there's a major earthquake, I do live in California, while I have this map open, I just want it to be there. And so you can choose to have a refresh interval. And what that means is it'll take the data and make sure it's showing the latest and greatest every so often. Now, go ahead, Tom.
So if I left this map open for my students all day long, I could just set the refresh interval and I'd continuously see updated data every time I got a new batch of students in the classroom.
Exactly. So you don't have to worry. Did I shut it? When was the last time I panned out? When did I zoom in? Maybe I'm not showing them the latest earthquake. You'll know because every so often, now it's not continuous. You do have to pick an interval, but it's better than never, right? So we turn on that option and you can do an interval, say every 5 minutes is good enough for you. Now living in California, I'm probably going to want it a little more frequent, and I can even go as low as 0.1 minutes, which is pretty often to get this data refreshing. And that's not really needed here. So we're going to go ahead and back it up to 5 minutes again and go ahead and click away. Now that is a setting on your layer that saves for you. So it sometimes makes me nervous when there's not a save button to understand what's happened, and I'll go peek again and you can see, yep, it remembered my 5 minutes. So just by setting that, it's gone ahead and saved it. Now again, I'm not signed in, so I can't save the map, Tom, but I want to turn it back over to you. Did you notice what happened when you talk about the projection and where these dots appeared?
I saw that. They seemed to snap right into place.
They did. So that's one of the really cool things with this is that even though it's in different projections, one was latitude and longitude, one is the Robinson projection, because we're using an online map, it helps mesh those two together and you are seeing the points in the correct location.
That is very cool, and that does exactly what I was looking for. I appreciate your help.
Awesome. Well, I'm not signed in, so I can't save it and share it with you. So you're going to have to watch the video later and recreate it yourself.
Not a problem. Thanks, Kylie.
No worries. All right, Joseph, it's all you. Take it away.
Greetings all. Joseph Kursky here. And what we're going to do in this segment is talk about global positioning systems. I loved what Tom and Kylie and Charlie was showing you earlier. To me, it is exactly why we are so excited about this. You've got live feeds, you can do multiple projections, etc. Another thing I liked about what they were sharing is that they talked about Arthur Robinson and the Robinson projection. Now, he was at the University of Wisconsin, go Badgers, for 33 years in the department. That's quite a significant accomplishment. I think that some of us would love to have a projection named after us. Anyway, but he was one of the best cartographers that I've ever known. I'd actually met him a couple of times. What a huge honor. Anyway, this section here, we're going to talk about GPS, Global Positioning Systems. And one of the reasons why is because it connects so well to what my colleagues have been chatting with you all about. Tables, working with tabular data, latitude, longitude, the fundamentals like Charlie started us off with, data integrity. How good is your data? How do you decide how good it is? Accuracy, scale, field work, tying into getting students out in the field, and the fundamentals of geospatial technology itself. Okay, so there's lots of reasons. First of all, Geo Technologies. Let's talk about that term for a bit, ever so lightly. But Geo Technologies, location analytics, geomatics, geoinformatics, those are all equivalent terms. And my colleagues and I, we don't really care what it's called as long as there's spatial and critical thinking in there. But Geo Technologies includes geographic information systems, which is often defined as a way of making spatial decisions or spatially enabled decisions, geographic decisions. And oftentimes it's defined in terms of its components. You've got some hardware, you've got some software, increasingly online, as you've seen here in the Mapping Hour presentations, data, spatial data, methodologies, how do you actually work with it, and people, the network of people. And so that's one component of the geotechnologies, but GPS is another component, global positioning systems, we'll talk about in this segment. Also remote sensing, looking at the world from space, from UAVs, from Landsat and other satellites. And finally, web mapping. And again, GPS, let's get into it just a little bit more. There's a ground component, as I'll explain in a moment, a satellite component, and a user component. It's tied really well to bridging boundaries, or breaking down boundaries, I guess I should say, between disciplines, which is why many of us love teaching with geotechnologies. There's a math component in here. It's good old distance equals rate times time, as I'll explain in a moment. Also, I think it's important to mention that GPS nowadays is really part of GNSS, Global Navigation Satellite Systems. And that the reason why is because GPS is really the American version of Global Navigation Satellites. That's the USA's GPS constellation of satellites. So the USA owns those satellites and makes them available to the globe, but it's the USA's flavor of it. There's Galileo for the European Union, there's Beidou in China, GLONASS in Russia, for example. We're going to talk about this in a bit, but why teach with GPS? Again, this is tied to the shape of the Earth. It's the fundamentals. It's how we know where we are on the planet's surface. We have this oblate spheroid, right? It's a little bit wider around the equator than around the poles. And everything we do in a GIS, whether it's on the web or on desktop software, is tied to how we actually measure the shape of the Earth. And GPS helps us do that and figure out where we are on it and where we've gone across the surface of the Earth. And GPS is really tied to this whole idea of absolute location. And a little bit of a teaching moment here. You might describe this to students or your kids, if you're teaching your kids right now, about relative location. Okay, we're going down to the library, and we turn left at this traffic light. We go down the hill, and it's across the street from the park. Those are relative locations. Absolute locations are street addresses or latitude, longitude, as Charlie was getting into with you all. Now, GPS, just as another side technical note, is different from RFID, or radio frequency identification. RFID uses a reader that transmits a low frequency RF signal to an RFID sticker. Think of the stickers that you've seen sort of in a library book, for example. The sticker is only made of metal and silicone, but the electrons in the sticker become excited and begin to flow from the signal, causing the chip to wake up and transmit some sort of information. So GPS is a bit different from that, as I'll explain here. Now, one of the reasons, again, why we like teaching GPS is because it's tied to what Charlie was talking with you about, how the equator is the x-axis and the prime meridian is the y-axis. And so we've got these positive and negative values if we use decimal degree coordinates. More about that in a moment. And in this next section, I'm going to talk about and demonstrate some ways to teach with GPS. But before I do that, folks, let me just go ahead and show you this. I'm going to share my screen right now and show you one slide from a resource that Charlie and I are going to discuss with you at the end. It's a set of slides that describes the GPS workings, how it works. And the distance equals rate times time thing, we know how fast the signals are traveling. And basically, it's at the speed of light. So that's the rate. So what we have to do with GPS is figure out a really accurate time, both for the ground system and for the satellites themselves. Once we can calculate the distance from those time signals, we're going to be set with our location on the planet's surface. And one way that you can use to teach with this is, hey, Arcgis Online. So for example, Kylie and Tom and others in the workshops here have been talking about earthquakes. You know, we don't have a seismic station for every square meter of the Earth's surface, right? So the way that these earthquakes are listed on the site that Kylie was explaining to you all is preliminary determination of epicenters. And the reason why they say that is because we don't have a seismic station under every square meter of the Earth's surface. All we know is this kind of information. The P and the S waves, the compressional and the secondary waves from an earthquake were received at, let's say, a seismic station in St. Louis. So we know they're in this circle somewhere, or along this circle. Now, they were also received at a different time in this Oklahoma City seismic station, and we know they're on this circle somewhere on this radius from Oklahoma City, because we know when they were transmitted and when they were received. And then there's another seismic station, say at Atlanta, and we know that that earthquake was received at a certain time, and it's got to be on this circle. And so the intersection of all those circles is an area that actually is prone to earthquakes, and that is the New Madrid Fault, let's say. It's at the intersection of all those three circles. Now take that into 3D, you need 4 instead of 3. You need 4 satellites to determine your exact position on the Earth's surface. Now, what do I mean by exact? More about that in a moment. let's take an ArcGIS Online map here, and I've got a coordinate, for example. This will build on what Charlie was going through with you all a little bit ago. We can, as you know, in the upper right-hand box, insert a mountain peak, a school, any location, city, etc. We can also insert a latitude, longitude. Now notice that I've got minus 00092, comma 51.47, kind of an interesting place. Where is this? I'm going to add that to the map notes. This is the Royal Observatory, okay, in Greenwich. Why is it there? It's there because of the prime meridian, right? It's there because the observatory was there, and the International Meridian Conference in 1884 got together a bunch of countries and say, okay, that's going to be the location for the prime meridian. The equator was pretty much set, right? We had to put it there, but the prime meridian could have really been anywhere. The reason why I mention this is because you can use coordinates to teach these fundamentals about GPS and positioning. So for example, if a student had put positive 00092, it would have been a little bit east, right? It would have been in positive zone. It would have been in the Eastern Hemisphere. So sometime, coming back to what Kylie was going through with you all, your table of data, if you've got a missing or an included minus where you should have had a plus or vice versa, and your points are over in Kazakhstan somewhere, then it's a teachable moment. You say, oh, did you miss the deleting minus sign if you're in the Southern hemisphere or the Western hemisphere? You need to have those negatives on there. Inside that map, I put a place marker. You know how to do that in ArcGIS Online. And I've added something that Charlie and I get really excited about, and that is the Graticule. It is a grid of latitude, longitude lines. And you can see here that it is at 1 degree of latitude, longitude mesh. And then when I zoom out, remember that visibility? And when I zoom out, it's only giving me the 5-degree grid. The nice thing to teach about this is, why aren't these perfect squares? Where are they perfect squares? They're going to be perfect squares if I scroll down toward the equator, right? They're going to be more and more of a perfect square. And so there's another way that you can teach about why the longitude lines converge and they're converging at the poles. Another thing that we wanted to mention here that we feel is important when teaching about these concepts is when you get data from your GPS device or from your app on your phone, and we'll talk about that briefly in a moment, you're going to get several kinds of data. One of which is going to be a waypoint. A waypoint is something that you saw this with Kylie a moment ago, where you can attach additional information like a photo, but it's sort of a virtual stake in the ground. I want to put a point right here. I can do that with my phone. I can do that with a GPS unit. So that's a waypoint, a place that you actually want to mark. You will also get from various devices and tools a track. So this is a sort of a virtual breadcrumbs that drop along at certain intervals that you can change in terms of, you can drop them every second, you can drop them every meter, you can adjust all those things. But this is basically where I've been, and that's what GPS also provides you. What you're also going to get are a set of track points that connect the track line. Okay, so each of these is useful. It's not like one is better than the other, but you get different kinds of data in these. In this case, I've got 164 track points, right? I'm just opening the table. I've got one feature only in the track line, and then I've got one thing in my map notes. Okay, so track points, track line, and waypoints. So let's get into, just ever so briefly, should I use my phone? Should I use an actual GPS unit? Now I'm holding both of them in my hand, and you can see relatively easily, although my phone's a little dark here, that they're recording the latitude and longitude. They're not exactly the same number because of, again, like we touched on earlier, what are your accuracy requirements? So there is a way for you to, and many teachers and professors that we know, tap into a higher end GPS device, an actual Trimble or a Topcon or something like that. There's even things that go on your phone nowadays that give you additional spatial accuracy. Okay, more about that in the document that we'll share at the end though. So they're both good, and you can also do some nice experiments with your students out in the field about the precision and accuracy of these points. So I've got all kinds of reports online in GeoNet about tests that I've run with this concept, using a phone, using an app. We'll talk about that in a minute. Now let's take a look at this. This should look pretty familiar to you all. This is in ArcGIS Online, and I've got a couple of waypoints. Remember we talked about that a moment ago. So I took a nice hike out in the chaparral one time when I was over by where Kylie is in Redlands, and I collected some data. So in this case, I collected data with a app on my phone. Okay, it's called Motion X GPS. It emulates what you have in a GPS receiver. So here's my track and my track points from my Motion X. How did I get that into ArcGIS Online? Well, very easily, just kind of like what you went through with Kylie. Remember this add button? One of the things that you can do is you can add layer from a file. And look at this. One of those formats is called GPX. It's an XML, or an extensible markup language version of the data that comes in from your app or from your GPS unit. So that's one of the files that you can actually easily ingest here. That's how I got it in here. It literally took me add, and there it goes. Okay, 15 seconds. So the reason why I'm showing you this is because I also have, hey, a CSV from a table from my actual GPS unit. And those are my points that came in. I can look at those latitude, longitudes. This is in the Western Hemisphere, so all the longitude values are negative. So I've got that in my map as well. Now, one of the things that I wanted to point out here is on that notion of accuracy. Notice the position of the trail on the image and my position of the tracks. Now, this is a very steep area. So my hypothesis is that as I was either going up or down that trail, the position was compromised a bit. Now, how much? Well, we could measure it with the measure tool. It's about 11 meters off of the image. Now, how close was the image? The image has been manipulated as well. So be careful that you don't just automatically believe that the image is 100% down to the sub-centimeter. But the point is, these are the kinds of things you can do with students. Now, back on my accuracy note, there was a big ridge off to the west. And my hypothesis is that those GPS satellites off to the west were not visible as I was going as I was walking on the east slope of this very steep set of hills. Another thing to point out at this point, folks, is that the signal that you're getting on your phone is actually a combination of GPS, Wi-Fi, and cell phone tower triangulation. So you're getting a bit of an enhancement over a GPS unit. But as you can see here, if you compare my GPS versus the cell phone, sometimes the GPS is better, sometimes the cell phone is better. So again, it's a nice thing to be able to just teach those concepts with the students. Couple last things here as we close out. There are some capabilities. For example, here, you know that you can make a 3D scene, right? Why not bring your GPS data from your phone or from your GPS unit into a 3D scene? And you might be able to see here if you look really closely, but every one of the points that the track points that I have here is actually a little person hiking. So that was just a kind of a fun symbology thing. But isn't it fascinating to be able to go out and collect data and then, okay, here's where we went on our field trip with these tools. 3D scene, here again, Chaparral Hills of California, much relief. It was an easy thing to do, simply add data. Inside that document that Charlie and I will share are a couple of geocaching sample activities. I like to create a story around the geocaching event. So geocaching is a virtual treasure hunt. Many of you might be familiar with it. It really came into vogue about 20 years ago, and a lot of people are still very passionate about geocaching. But you can also do it on your school campus, for example. So I like to design these fictitious scenarios, and this one is all about, hey, there was a silver map back in the 11th century, and you found some clues to be able to find that map of silver. And here are the coordinates on the grounds, in this case of an environmental education center, where you need to go and look for clues, and you're going to use your GPS or your cell phone to actually find those things. Another set of tools that we could talk about are related to this whole idea of GPS location. One of my favorites is something called Mapillary. And what Mapillary does is it allows you to do this sort of thing. So you've seen Google Street View, right? As you use Mapillary, you're basically collecting your own Street view or your trail view, as you can see here. I was walking along a big circular route in a park in Melbourne, good on you mates, in Australia back in September, and I collected a Mapillary track, and you can map it that way. And you can use that, of course, as a activity or a tool. And the nice thing about Mapillary and some of these other tools as well is they're actually helping collect data where there was no street view. So communities can figure out what their infrastructure was, their curbs, their light poles, their street facades, etc. Okay, last piece here, folks. I have a set of podcasts, and the one I produced this month is actually about latitude and longitude. So if you're interested, you could hear me going on and on about the wonders of latitude and longitude. And the last thing, as promised, Charlie has inside the K-12 org this whole zone of GPS material. So again, we didn't cover it adequately here, I realize, but what is GPS? How to use it? GPS and GIS, a more perfect union. Recommendations on GPS receivers. Yes, they still have their place, even though we've got lots of nice tools here on the phone. We'll talk about Survey 123 and a couple of others down the road here in the mapping hour. So I'm going to close it off there. I hope that was valuable, just as a bite-sized, gluten-free chunk of GPS, and look forward to hearing your comments. Thanks.
All right. So what did we go through? Data, tables, coordinates, and GPS. Simple names, some really important concepts here. Data tables with rows and columns, features and attributes, and you can see them in an earthquake table and in a GIS table on the map. Coordinates and the decimal degree structure, that's what allowed the software to be able to drape those earthquakes onto the map, that Kylie somehow magically had them go in the right place because they were in a decimal degree format, and the software was able to read that and make sense of it. And GPS that everybody's going to be living with from now on, and the waypoints and tracks that are important for all of the context of what you're doing on the map. And some resources here from the K-12 organization. If you were really interested in looking for that table time document, there's the URL for it, and the recent quakes map that Kylie was working with, you can see at that address. One of the really interesting things in preparing this set was thinking about the high school and middle school competition. In that competition, students have been generating their own data and bringing it into the map. And so you can see how they've been doing that. And at esriearl.com/mapping hour, at our hub site for the Mapping Hour series, remember, you'll find the other videos. And once again, if you need a login, that's where you can get it. Over on the right-hand side, we've got one of the sites from which you can find a variety of really interesting activities and lessons. The Teach with GIS site. There is an interesting one about adding point data. And this is a nice, pretty simple one, pretty straightforward. Might be of interest for you to at least to go in and take a look at that, possibly even to get access to it. And then if you really want to dive in deeply with GPS, this is the zone where you can see Joseph's GPS resources. Now, let's see. Looking at this from last time, I can see that this is in the education org. This is an Arcgis Online org. There's the home, and here's a group. So this is in a group. The group has its 32-character ID string, and you're in the overview section of it. Hey, I can read this. I was in the last class. I can read the metadata. That's why it really matters. So that's where we have been, And now you get to go out and practice. All right. Thanks for joining us. We'll see you next time.
Bye.
Bye-bye.